Go ahead, Jesse.
So the initial position, the object's traveling at a straight line, as position x of t at time t, and the initial position at x of 0 is 2. Does that mean like it starts at 2?
So what it means is you have a particle, it's moving in a straight line, but it can go both directions along that line.
Yeah.
The center of the line we call the origin, and another name for that would be location 0. Okay, if the board in front of the room, the center of the board is the origin, I'm going to say the edge of the board is location 2. They're saying one of three things could be happening. If I'm the particle, at time 0, I might literally be stopped and sitting here. But I could also be doing this. Prior to time equals 0, I might be moving like so, and then I'm getting closer and closer. Right at time 0, I'm right here, but I keep going. That's
Okay.
all that's saying.
Wait, what was the, like, what do you mean? Like, you can, you can travel?
Oh yeah, the particle could have been moving at time 0 already. Time 0 is just a reference. It's just like when we say it as time 0. Like the moment we say, we want to start our experiment, like think of it as a car. Like you're standing by the road, and you've got a sign right here, and you're calling, this is location 2.
Okay.
And cars are coming, and you pick out a car and you say, okay, when that car gets to right here, I'm going to say time 0.
Oh, okay.
That's all they're saying.
Okay.
Does that make sense?
Yeah.
Okay.
And then the velocity of the object is the gradient.
Yeah, that thing.
And then what is the position of object time course? Like, so like we have a rate, and then we're finding the position, right?
So you have a rate, we are finding an amount.
Yeah. But then how do you do that?
So look at your golden notes. Look on the front side for this box right here.
Oh, I see it now.
So that box says you have a rate, looking for an amount, you want to use fundamental theorem.
Yeah.
And the one we want is right here, actually.
So then, but like the integral, do you do it from 2 to 3?
Let's write that down. So the integral of what?
2 to 3.
No, right. What are you integrating?
Integrating the velocity.
Good. Let's pause there for a second. Okay, look at your golden notes again. Right here. Whenever you integrate a rate, you discover how much the amount changes. So in this case, the amount is what? The amount is position.
3.
The amount is position.
2.
Well, the amount is position.
The amount is.
The amount is some position.
Oh.
Now we know the position at different times.
Yeah.
With me?
Yeah.
What's the rate in this problem?
The v.
The
velocity?
v. Because velocity is the rate at which position changes.
Yeah.
So what we want to do is we want to integrate the rate to find how much this changes.
Yeah.
So yes, we want to integrate from time 0 to time 3. Let's do that. So grab your calculator. Integrate, like do this integral. Like I'm kind of going, in a way, I'm hoping this will help stick in your brain better. Good. Okay, so you tell me if you can. If you can't, it's fine. What does the 4.512 represent?
Represents the position from 0 to 3. The position. Yeah.
It's not the position from 0 to 3. It's how different the position is between 0 and 3. So it's saying that the particle is somewhere, okay? Somewhere at time 0, And now the particle moves however it moves, but 3 seconds later, it's in a new spot.
So is it like displacement?
It's displacement. This value here is 4.5, I'm just rounding so we can talk more easily. So that's what the integral is telling you. It doesn't tell you how the particle moved. It could have moved a lot more,
Okay.
but ultimately the difference between where the particle was at time 0 compared to where the particle is at time 3, that difference is 4.5.
Yeah.
That's what the integral tells you.
Uh-huh.
But what is the question asking you to find?
The position of object times 3.
Right, it wants to know where is this? It's like we have this line and we've measured it. And we marked it off with positions. And we want to know where is the particle now on this line?
Then you add 2 because position at time 0 is 2.
Very good. Knowing this alone won't ever tell you where the particle is.
Okay. Because it's just a displacement.
Yes, very good. So I have to combine that with this. So this is what you're doing. This is how you use the fundamental theorem.
Mhm.
Does that make sense?
Yeah.
Your final answer is 2 plus this, which means your position is now 6.512. Of course, they gave this answer to try and trick you into choosing it.
Yeah. Gotcha.
Any other questions here before I stop the video? Melissa, go ahead.
Okay, number 85.